Exercise 709 is about areas enclosed by the x-axis. So what we see here, these areas above the x-axis, they're always going to give us positive values. And you could try that by doing some integrals. If you find the integral there, you get a positive answer. If you find an integral that goes below the x-axis, you get a negative answer. So if we were asked to find this area, you would need to find the absolute value of that integral. So just a quick note about odd and even functions. If you've got an odd function, then it's symmetrical about 0, 0. It's got rotational symmetry. So the area from negative a to a, this area here would be the same as that area there. So the integral would equal 0 because they would cancel each other out. One's positive, one's negative, and they're the same size. For an even function, the integral from negative a to a, because of the symmetry here, you can just do 2 times the integral from 0 to a of that function. So that's just a nice little handy trick that you can use. So let's have a look at this example. So you're asked here, given that a, b, and c are areas, so they're all going to be positives, find the integral from a to b of f of x with respect to x. So what we need to do, a is a positive number, a is an area, so the integral, this from from a to whatever a is, it's a negative number, but from a to 0, the integral in the area would be the same. The integral from 0 to this point here would be the negative of b. B is a positive area, so we need to minus that. The integral is the negative of b. And then from this point to b is positive, so the integral and the area are the same. Okay, let's look at these examples. So find the area enclosed by the curve y equals x squared minus 9 and the x-axis. So it's really important here to always find any x-intercepts and sketch it. So it is a parabola shifted down 9 units. So our x-intercepts would be 3 and minus 3, but we should show that working out. So where does x squared minus 9 equal 0? We could factorise difference of 2 squares if we wanted to, or do it this way, plus or minus 3. So our x-intercepts are plus or minus 3, and that gives us the endpoints of our integration. So the area here would be equal to the integral from negative 3 to 3 of our function with respect to x. Now, because it's below the x-axis, we need to take the absolute value. Now, the other thing that we might note here is that it's an even function. So that would actually be equal to 2 times the integral from 0 to 3 of x squared minus 9 with respect to x. And that's actually much easier to do because plugging in 0 is going to give us better numbers. So this is the version I'm going to use. So it equals absolute value of 2 times, let's integrate. So x cubed on 3 minus 9x, and 2 times, because I'm using this one, so our endpoints is 0 to 3. I could leave off that 2 and go negative 3 to 3 if I wanted to. Close the absolute value. So let's plug in those endpoints. So 3 cubed on 3 minus 9 times 3 minus 0 on 3 minus 0, so that's just 0. Now that's pretty obvious, but you still should show that working out. And if you put that all in your calculator, you get the absolute value of negative 36. So the answer is 36 units squared. Because we wanted an area, we have to give the absolute value. Here's a second example. Find the area enclosed by y equals sine x, the x-axis, and the lines x equals negative pi on 2 and x equals pi. So I've drawn a sine curve. X equals negative pi on 2 is here, x equals pi is here. Now, interestingly, if I'd gone negative pi to pi, I would have got 0 because it is an odd function, but I didn't. Now what we're going to have to do here is actually break up our integral a little bit. So the area equals this piece, which is the absolute value of the integral from negative pi on 2 to 0 of sine x with respect to x, plus the integral from 0 to pi of sine x with respect to x. I didn't put the absolute values here because it is positive. Now, here's something really cool about the sine curve and the symmetry of it. If I drew an extra line there, this area here is exactly the same size as that area and that area. So what I can do if I want to is do 3 times the integral from 0 to pi on 2 of sine x dx. I don't have to. I could just do all of that and add it up, but this is a nice little shortcut. And that's a positive one, so I don't need absolute values. Okay, let's do it. So sine x integrates to negative cos x. And that's from 0 to pi on 2. So that's 3 times, plug in the pi on 2, so negative cos of pi on 2, minus, plug in the 0, minus negative cos, so let's change that to a plus, cos 0. Now, if you're not sure what these values are, a quick sketch will help. So the cos curve looks like this. That's pi there, this is pi on 2 here. So that equals 3. Cos pi on 2 is 0, so negative 0. Cos of 0 is 1. So that all equals 3 times 1, which is 3 units squared. One of the cool things about the cos and sine curves is you do get these nice numbers sometimes. So this area here is 1, that one is 1, and that one is 1. This whole area is 2. It's nice to know, but if you're asked to find that area, you still must show all the working out.